Hello everyone, this is Siddharth, and in this video we will be solving another question from the list that I have shared in the starting of this playlist. So if you don't know what we are doing, we are making a playlist, and in that playlist we are solving all those questions which are related to each other, so that we can able to build patterns and able to memorize all the standard processes and methods and able to solve the question intuitively in the interview and in the contest as well, using those concepts. So let's start solving this question as well. So currently we are on two pointer approach, and in the two pointer approach we will be like using two pointer, but one pointer will going to be fast and one pointer will going to be slow. So I will suggest that you can start, you can watch my previous video as well, so that you can able to get idea about this question. As the previous question, you can get intuition for the next question as well. So let's start solving this question. So what we have to do, we have to rotate this linked list uh, to the right side by k places. Suppose this is 1 2 3 4 5. If you want to rotate it by two places, then this 1 2 3, this 4 will become a new head, because as we have to rotate it to the right side, so this will come at the starting of this linked list, and then 5 will come, and then 1, and then 2, and then 3. So let me tell you again. So 1 is connected to 2, then 2 is connected to 3, and 3 is connected to 4, 4 is connected to 5. Now we have to rotate it by two places. So what will happen is 5 will come here, and then 4 will come here. So this will look like 5 is connected to 4, 4 is connected to 1, 1 is connected to 2, and 2 is connected to 3. Now here we have to handle, obviously we will be using two pointer approach. One pointer will going to be slow and one pointer will going to be fast. But in the previous question, we can able to solve this question using those two pointers only, and we don't even have to calculate the length of the linked list. But if you will like try to think and try to solve this question using two pointer only, then you will not able to solve it. Obviously you have to like calculate the length of the linked list. So for that we will be using, we will use the standard process to calculate the length of the linked list. Then we will move our tail pointer or the slow pointer to the end of this, or we can say length minus k minus 1 node, so that we can get the new tail of our linked list. And then uh, we will point this next to the null, as this will going to be the new tail of a new linked list. And then we can point our tail dot next to the uh, to the head of this linked list, so that a new head will become this 5, and we will be having a linked list whose head is this 5, which is the new head of the linked list, and then 4, and then our previous then our original head of the original linked list. So this is the concept that we have to use. And another right case will going to be if k value is greater than the length of the linked list, then we can take modulo, or we can take modulo, so that it will come between the range of the length of the linked list. So why this work? Because if you will try to rotate it, suppose the k value is 6 and the length of the linked list is 3. So no matter how, sorry, this, let's take this as 7. So if you will like rotate it by 7 and try to see, then you will see that if you will try to take modulo of this 7 with 3, the answer that you will get, you just have to rotate it by that place, the remainder you will got. So that's why we are taking modulo here. Now let's try to solve this as well. So obviously what we have to do, uh, first we have to check for the edge case. So if head is equals to null, if we have a null linked list, or head dot next is equals to null, and otherwise k value is equals to 0, then in this case we just have to return head, because here in this case we don't have to rotate anything. Now what we have to do, we have to calculate the length of our linked list. So let me define the length variable. and we will be initializing it by 1, because when we will move our next pointer, the one length we already have processed. So that's why now we have to make a list, a new node, and eventually this node will be pointing to the tail of a original linked list. So we can name it as tail original is equals to, it will be pointing to the head of the original linked list. Now we just have to use the while loop. While this tail original does not point to null, we have to like increment it. Let's copy paste it instead of typing. So this will going to be dot next, and then we have to increment our length plus plus. So this will calculate the length. Now we have to check, we have to like divide the k value as well. So k is equals to k modulo it with the length, so that the k value will come between the range of this linked list. And I would suggest that you can try for one or two cases to check whether this k value is resolving to the right value. So, and if you will try, you can like able to see that this is the correct approach. Now after like taking modulo it with the length, now what we have to check, if k is equals to 0, what what does it mean to use this condition is that if the value of k become equals to 0, then it is the multiple of the length. So in that case we don't have to rotate anything. So because no matter how much you rotate, you will come to the original linked list position. In this case we just have to return head, and now we have to calculate the new tail of our linked list. For that we can make a node. So list node new tail is equals to, this will be pointing to head as well. Now we have to use an for loop that will be starting from 0, and I should be less than length minus k minus 1, and then I plus plus. So let me tell you why. Because first, for this case, as k value is 2, so we will be running up to 3, because we have to separate this linked list 1 2 3 and then 4 and 5. For that we have to move our this new tail. Our new tail will going to be 3. That's why we are moving this, we are using this for loop up to length minus k minus 1 time. And sorry, for this iteration, if you will try to run this for loop, then our this new tail pointer will be pointing to 3. So new tail is equals to new tail dot next. Okay, so this will be pointing to the 3 for the first iteration. Now after finding this new tail, what we have to do, uh, we have to we have to point our head, we have to point this to the null, because this will going to be the new tail of our linked list. That's why we have to point this to the null value. And then this new tail dot next will going to be a new head. So for that, let's make it as well. So list node new head is equals to, uh, new head will be pointing to this new tail dot next. So new tail dot next. So this 4 will going to be our new head. So we have just store it so that we can point it to null. So now we can point it to null. So new tail dot next, we have pointed to null, so that it will be our new tail of our new linked list or the modified linked list. And after that, what we have to do, we have point this 3 to the null, and we have make our new head, uh, which will going to be 4. And then what we have to do, we have to point our we have to point this 5, or we can say we have to point this 5 to the head of our linked list. So for that, what uh, we can use our previous tail, that will going to be tail original. As it is pointing to this 5, now what we can do, we can point it to the uh, head of our original linked list. So what we can do, we can use this tail original is equals to head. So what it does, let me tell you. So So 1 2, sorry, 1 is pointing to 2, 2 is pointing to 3. So this is a new tail. We have already calculated it and pointed to this 3, and it is pointing to null. So one linked list will become this, and another linked list that we have is this, and our previous, or we can say original tail is pointing to this 5, and our new head is pointing to 4. Now you can see uh, what we just have to do. This is our original head. So what we have to do, we just have to point this 5, uh, we just have to point this 5 to our head, and then make this 4 as our new head of the modified linked list. So what we will do, we will point this 5 to the original head. So this will look like 4 is pointing to 5, 5 we have just make it pointed to 1, then 2, and then 3, and we have just make it pointed to null. So this is our required modified linked list. And another edge case, if you will try to see for this k value is larger than the length of the linked list. So we are just dividing it by the length of the linked list. So this will become k, new value will become 1. Now we just have to rotate y k 1 places. So, and you can see as well, so original linked list is 0 1 then 2, and if you will try to rotate by 1 place, so it will look like 2 is pointing to 0, 0 is pointing to 1. So this is a modified linked list. So now let's return this as well. So we just have to return a new head. So what we have done till now, we have calculated the length of the linked list, and then we have pointed this tail original to the tail of the original linked list that we have given in this question. And after that, we have modified a k value so that it will come into the range. If it is greater than the length, then we are taking the remainder. Otherwise, we are taking the k original value. And if k is the remainder is 0, this means that k is the multiple of length. Then we don't have to do anything. And then we are like making a new tail that will be pointing to head, and then it will moves up to the new tail of our modified linked list. And then we are pointing this new tail dot next to null. That is, new tail is here, and new tail dot next we will be moving to null. And this new head is will going to be 4, that will going to be new tail dot next. And then we are returning this uh, new head that we have just made. So now we can try to run this. Okay guys, so there is an issue. So let me see. Okay, so this should be tail original dot next, otherwise we will not able to calculate the full length. And now let's try to run this. Okay, so there is another issue. Let me see. Okay, so we are getting just this. So we are not connecting 5 to 1. Oh, okay. So this should be tail original dot next. We have to point it to the head as well. We are just like pointing it to the head, not its next value. Now we can try to submit it. Okay, so we have successfully solved this question. See you in the next video. Bye.